stored at address 7000, the compiler will simply generate the code to call the function at 7000. Okay? So what's the benefit of that? Benefit is the code will run pretty fast because it will directly go to the function, make the call. Okay? What's the danger of that? The danger of that is, in this case, it's calling the wrong function. Okay? The programmer actually allocated my compute, so it should be this one that should be called, right? So C# at least gives you a warning. Are you sure you want to do this? So you'll get a warning. So anyway, so that's why you will mark it virtual. And now, what's the penalty we are paying for this? The penalty we are paying is there's quite a bit extra code. It has to go over here, find the vtable pointer, go to the vtable, locate the function, then make the call, right? So coming back to Java, why Java does not have virtual keyword? See, when Java was created, the designers of Java thought, let's not confuse the programmer, okay? Let's make programmers' life easy, so all public functions in Java. So if you create a class, you write a public function, are virtual by default. So that means every time you make a function call in Java, it will go through the vtable, okay? Whereas designers of C# thought, okay, what if you are not using inheritance? Okay, why should we slow things down? Why should not we be able to call it? And same thing in C++. So C++, you have an option also, whether you use the virtual keyword or you don't use the virtual keyword, right? But anyway, so hopefully now you understand what those three keywords mean and how they help us in writing code where the programmer's intention is not is followed. Okay, go ahead.
So in Java, there is a keyword for the super keyword, right? For referencing
for the base class.
For the base class.
Correct.
If all the classes are marked virtual, then how does the super keyword work actually?
Well, super keyword has a totally different goal. So for example, let's say you created some base class. You wrote, let's say, 3 functions, right? Suppose I call them F1, F2, F3, right? And now from here we inherited, so let's say this is class A. Suppose this is class B. So we inherited or extended this class, right? Okay, so now suppose I have some function over here, F5, which has nothing to do with inheritance. And suppose this wanted to call F3 as an example. So using the super keyword, you can say super.f3. So, so that's a capability to call any function in the base class. In C#, what's the equivalent of super? Base. Okay. So anyway, so now let's come to the next concept in finishing our basic object-oriented programming.
I have a question.
Sure.
If we make the method virtual in a base class, but we didn't override that method in derived class.
Okay.
So how?
What happens to that method?
Yeah.
Okay, good question. Let me answer that. Okay, suppose you created a class. Again, whatever x, y, z. You created some method over here, let's say F1, and you marked it virtual. Okay? Then from here you created another class, let's say PQR. Okay? And you did not override F1. Okay, so no override of F1. Okay? So so what that means is, remember, once we inherit everything. So this method is also over here, even though we did not override it. And it continues to stay virtual over here. Okay? So if you go further down, here you can do an override on F1. Okay? And if the compiler And if you wrote some code, let's say PQR, P1 equal to new, let's say, suppose this is LMN or whatever, new LMN. Okay, so, and then you did P1.F1. Okay, so again, what the compiler will do is start from P1 and come over here to see if there's F1 declared. Okay, there's no F1, but it's inheriting from XYZ. So the compiler will go to the base and see is F1 declared virtual. If it is declared virtual, it will generate the code to go to the V table and call this correctly. Okay. Okay, so now we need to move to the next important concept in, again, basic OOP. So like I said, hopefully end of next week we'll finish the basic OOP. Then we'll move to the intermediate level object-oriented programming, and then the advanced OOP. So that's how we are progressing. By the end of the course, you'll be top-notch programming expert. Okay, so anyway, it's very important that our foundation is good, so we are spending some time on these basic concepts, even though many of you already hopefully know these concepts, but no harm in strengthening these concepts. So, coming back over here, now we know exactly what encapsulation means. This is the class mechanism, the public, private, protected type of keywords, right? Inheritance, we exactly know how it works. How do we create classes? The concept of abstract, virtual, override, static, so everything hopefully should be clear. Okay, so now let's come to the next concept over here, polymorphism. Okay, so polymorphism, first let me explain the plain English language meaning of it. Poly means what? Many. Morphism basically means forms. So what do we mean by polymorphism when we apply it to programming? It basically means many forms of a function or method. Remember, function is also called a method in object-oriented programming. So that's all it means. Further, what do we mean by many forms of a function so all this means is more than one function with same name. Okay, so technically speaking, okay, even though some people may disagree with me, but there are three different categories of polymorphism. Okay, one is called, see, you guys have already seen more than one function with the same name. For example, remember whenever we were writing constructors, constructor is a function, right? So we had more than one constructor. We discussed typically we'll write two constructors, one without parameters, one with as many parameters as the fields inside a class, right? Okay, so anyway, over here, so function overloading. So whenever we write more than one function, it has the same name, we also call it overloading. Okay, so now overloading is always done within the same class. Okay, so again, very quickly to give you an example, let's say you created some class XYZ. Okay, you wrote some method over here, double, let's say public double compute AVG, int A, int B, int C, right? And you did return A plus B plus C divided by 3.0. Okay. Now, can we write one more compute ABG in the same class, which takes 4 parameters instead of 3?
Yes.
Yes, right? So if I went to the same class and I said public double compute ABG int A, int B, int C, int D, and I did a return A plus B plus C plus D divided by 4.0. So is this okay to have both be called compute ABG, right? If that is okay, in the technical terminology we say we have overloaded compute ABG, meaning there are 2 compute ABGs. So remember the rule we discussed was as long as the number of parameters or the type of parameters is different, you can overload as many times as you feel like it. So overloading is one form of polymorphism because we have more than one function with the same name. Okay? And once again, overloading is done within the same class. Okay? So within the same class, we have more than one function with the same name. As we discussed, we often overload constructors. That's very typical, right? What's the second form of polymorphism? Second form of polymorphism is overriding. Okay? So actually, let me do over here. Okay, overriding is done between a base and a derived class, right? So once we were doing inheritance, we've already discussed it, so you are already very good with overriding. You know, for example, when to use the abstract, when to use the virtual, when to use the override keyword, right? So once again, if I show you a quick example. So the overriding would be, again, you created some class called student, let's say, and whatever data you had, you did public string compute grade, for example, that you guys already did, right? And whatever the code